You have always been taught in an engine failure to pitch for your best glide speed. But have you ever wondered where that speed actually comes from? It's not magic. There is a really cool way to derive it. So over here, I'm going to draw a graph, and on the y-axis is going to be drag, and on the x-axis is going to be velocity or speed, airspeed. When we're flying an airplane, there are two types of drag that affect it. Induced drag, drag due to wingtip vortices, and parasitic drag, drag due to the friction between the air and the surface of the plane, and the shape and many factors. Induced drag is very high at low speeds, but it gradually gets slower as we speed up. So if I were to graph it, it would look something like this. At very slow speeds, it's high, and the faster we go, the lower it gets. For parasitic drag, it's the opposite of induced drag. At slow speeds, it's very low. And as we get faster, unfortunately, it also increases exponentially too. So if I were to draw that, it would look something like this. To draw the total drag, I would take the displacement from each of these graphs at each point and draw a single curve. That would look something like this. So at any speed I fly, drag is going to be defined by this curve. Of course, when we have an engine and we are getting propelled through the air, this drag up here is not much of a problem. But when we've lost our only source of propulsion and we're using gravity, this becomes really important. And now, the minimum drag, as you can see, is over there. If I was going to connect that to the velocity, we would get our best glide speed. This, ladies and gentlemen, is none other than the speed you pitch for when you lose your engine. For example, it could be 68 knots, as it is in the Cessna 172. This is the best LD speed or LD max. All it's saying is this is the speed where your total drag is lowest and you end up with the best number in this ratio. Now you can stop here. You can be satisfied with this and know that whenever your engine fails, this is the speed to pitch to, and it will give you the most distance and the best chance to land somewhere safe. But as we like doing on this page, we're going to go one step further, and we're going to see and we're going to prove that this speed does in fact give us the most range. And the proof is really beautiful.